Good evening, everybody. Today we will discuss the next topic of the photochemistry, that is Norrish type 2 cleavage. In the last class we have discussed Norrish type 1 cleavage, that is an alpha cleavage. So today we will discuss the next topic, that is Norrish type 2 cleavage, and it is a type of gamma hydrogen abstraction. So first of all, the gamma hydrogen is abstracted by the radical which is generated in the carbonyl group. Here also Norrish type 2 occurs in carbonyl compound. So first of all, you know that the carbonyl group are highly photoactive due to the presence of the three different type of electron: non-bonded electron, pi electrons and sigma electron. And the sigma and pi electrons are more active towards the photochemical reaction. And first of all, the loosely bounded pi electrons are homolytically cleaved, and to form the two radical, one is in the oxygen and the other one is the carbonyl carbon. And after that, the hydrogen which is in the gamma position is abstracted, and to form the new radical which is in the gamma hydrogen. Okay, then after that the alpha beta bond is cleaved and to form a alkene and enolate. Okay, so otherwise the radical which is generated after the gamma hydrogen abstraction combine together and to form a cyclic compound. So the gamma hydrogen abstraction is the primary process in Norrish type 2 cleavage. Then let me compare the Norrish type 1 and Norrish type 2 reactions. So in Norrish type 1, both of them undergo by the carbonyl group, and Norrish type 1 alpha cleavage will occur in the light radiation, whereas in Norrish type 2, first of all gamma hydrogen will occur, then followed by the alpha beta cleavage. So this is the difference between Norrish type 1 and Norrish type 2. Both the Norrish type 1 and Norrish type 2 is very important, but the speciality of the Norrish type 2 is there will be the hydrogen in the gamma position, then only we can do the Norrish type 2. And if the Norrish type 2 is possible, then the first preference is for the Norrish type 2. Okay. In some cases, in some example, both Norrish type 1 and Norrish type 2 is possible, but in that case, we have to give the first preference to the Norrish type 2. See here in this second example, we can see that alpha cleavage is also possible, but we have to give the more importance to the gamma abstraction, that is Norrish type 2. Now we are moving into in detail the difference between the Norrish type 1 and Norrish type 2. First of all, in Norrish type 1, primary process is the alpha cleavage. For that, first of all, the carbonyl is activated and excited to form the singlet state. Then it undergo the triplet state. In the triplet state, the chemical reaction will occur, that is the dissociation of the pi electron, homolytic cleavage of the pi electron of the carbonyl group, and to form the two radical, one is in the oxygen and the other one is the carbonyl carbon. After that, the secondary process, we already studied the four different type of the secondary process. First one is decarbonylation, recombination, hydrogen abstraction, or ketene generation. Any of the secondary process or all the secondary process may occur depending upon the structure of the starting material. Here the decarbonylation will occur, and after that the radical is recombined and to form a hydrocarbon. So in next Norrish type 2 cleavage, first of all the carbonyl group is activated into the singlet state. After that it undergo the triplet state. In the triplet state, the reaction, the cleavage will occur. First of all, the carbonyl group is homolytically cleaved and to form the two radical, one is in the oxygen and the second one is the carbonyl carbon. After that, the hydrogen which is present in the gamma position is abstracted by the oxygen and to form an enolate. After the enolate formation, either the combination of the two radical will occur and to form a cyclic product, or it may undergo the alpha beta cleavage. Usually alpha beta cleavage is the characteristic of second Norrish type 2 reaction. So alpha beta cleavage will occur and to form an enolate and an alkene. Okay, so most of the final product of the Norrish type 2 is an enolate and an alkene. Now we are moving into the next topic, that is photoreduction of the carbonyl compound. Since I already told you that the carbonyl group is very reactive to the almost all the photochemical reactions, since it have the three different type of the electrons. So reduction means it is the addition of the hydrogen. Photoreduction means it is the addition of the hydrogen in the presence of the light. So benzophenone undergo the photoreduction and to form benzophenolone, and which is carried out by the irradiation of a solution of the benzophenone and isopropanol alcohol with the wavelength of the 340 nanometer. So in which the first of all the pi electron undergo the excitation state, and it is excited to the singlet, then to triplet, and at the triplet state isopropyl is added. That means the hydrogen abstraction from isopropyl will occur, and the isopropyl does not absorb any radiation. Okay, so see the reaction. Benzophenone absorb the wavelength 340 nanometer in the presence of isopropyl alcohol and to form the final product as benzophenolone. So see, this is the mechanism. First of all, benzophenone absorb the radiation and excited to the singlet state. After that, it is converted, it is undergo the intersystem crossing and to form the triplet state. In the triplet state, the pi electrons undergo the homolytic cleavage and to form the radical. Here I have shown the radical by a half arrow mark. So the newly generated radical is in the oxygen. One is in the oxygen, other one is in the carbon. And this radical abstract a hydrogen from isopropyl alcohol and to form an enolate. After that, sometime the enolate combine with the enolate itself, and that means it is a dimerization will occur and to form a benzophenolone. Otherwise, the isopropyl radical combine with or isopropyl alcohol abstract one hydrogen abstract one radical, accept one radical from the homolytic cleavage of the CH bond and to form the propanol, and the hydrogen is clubbed with the radical of the carbonyl carbon of the ketone, diphenyl the ketone, and to form the ketenyl radical. So these are the different type of the product, and the ketenyl radical may combine with itself, that means dimerization will occur, and we also get benzophenolone. This is the photoreduction of the carbonyl compound. So the next example for the photoreduction, when the ketone in the presence of hydrocarbon and radiation, and in the presence of the radiation, first of all the carbonyl group undergo the excitation to the singlet state. Now it is moving into the triplet state due to the intersystem crossing, intersystem conversion. After that, it will undergo the homolytic cleavage and to form the two radical. One is in the oxygen and the second one is the carbonyl carbon, and the hydrogen is abstracted from the hydrocarbon. Usually we know that the hydrocarbon CH sigma bond is highly stable, but even in the presence of the light it will homolytically cleaved and to form an enolyl radical and CH2C6H5 radical, and the radical which is present in the enolate club together, that means dimerization occur and to form the final product. This is the final product, or it may club with the radical of the hydrocarbon and to form the new product. Okay, so the final step in the photo reduction means it is the homolytic cleavage of the carbonyl group and abstraction of the hydrogen from anywhere, from it may be alcohol or hydrocarbon. Okay, now we are moving into the another example. The photoreduction occurs in cyclic ketones also. So here we used the hydrogen source as alcohol again in the presence of radiation. So first of all, the carbonyl group undergo homolytic cleavage and to form the two radical. After that, hydrogen is abstracted from alcohol and to form an OH group. The hydrogen is abstracted by the oxygen radical. Okay, then after that it will club, that means dimerization will occur and we will get the final product. So next example is the example. See here, the carbonyl group is attached to carbonyl group means it is present in the aldehyde or it may be an acid group. So during the chemical reaction, the aldehyde group is very much reactive than the acid group. So first of all, the carbonyl group in the aldehyde decomposes and to abstract a hydrogen from alcohol. After that, it may dimerizes or it may undergo the rearrangement. Okay, now next example is the active methylene group in the presence of alcohol and radiation. So first of all, the carbonyl group of one of the carbonyl group of the active methylene is undergo the homolytic cleavage. So here also the carbonyl group in the ketone, that means attached to the alkyl group, is more reactive than that of the esteric carbonyl group. Okay, after that hydrogen is abstracted from the alcohol and the rearrangement occur and we will get the final product. Now we are moving into the next topic, that is photoenolization. Photoenolization means in the presence of only the light the enolization will occurs. So in which also the carbonyl group is highly reactive, it undergo the homolytic cleavage and to form the two radical, one is in the oxygen, the second one is the carbonyl carbon, and after that the radical in the oxygen abstract a hydrogen from the neighborhood, that is from the gamma position, and to form an enolate. Okay, so the two different type of the enolate and to form an alkene in the same molecule itself. And the alkene may be two different type, that is Z photoenol or E photoenol. Next is the photoenolization followed by the desalted reaction. Here also the keto group is highly reactive. It's absorb the light radiations and to form the enolization. And for the enolization, the oxygen radical abstract the hydrogen from the gamma position itself, and after that we are adding an doubly bonded organic compound which is attached to an electron withdrawing group. This is the desalted reaction. We have already discussed the desalted reaction, and to form a cyclic rearrangement occurs and to form a final product. Okay, here also the reduction will enolic compound is produced. Okay. Now next example, in which the ketone is highly active by the absorption of the radiation and to form a two radical. After that the hydrogen is abstracted and to form an enolate. So this is the example for photoenolization. So today we have discussed the Norrish type 2 and that is more important. And after that we have discussed the photo reduction and photo enolisation. I hope that you understood the section. Thank you.